electrostatics 10. Still, we are in that electric field strength only. Yeah, we'll focus on this principle of superposition of electric fields. In mathematical form, when you would like to write like this, E equals E1. I'm continuing from where we left in the previous class. E2 plus E3, so on. So this is the main idea. From where we can do a good number of questions. This E1, E2, E3 are what? The electric fields of individual charges. So keeping that in mind, let us do exercise. I'm calling it exercise because this kind of sums are not very difficult and we don't need to call them problems as such. This exercise will make you understand and revise the idea in a simple way. Okay, let me see. Number 1. I have a plus Q charge here and a minus Q charge there. What? So the distance between them is R. Exactly at R by 2, find out the electric field strength. Find out electric field strength. So this is a question. What do you do? The solution will be like this. I'll draw the picture again. So at the midpoint, you're asked to find out the electric field strength. So the electric field strength of plus Q will be away from plus Q. Electric field strength of minus will be towards it. So there are E1 and E2 like this. Actually, it is easy to say think of placing plus 1 here, but I don't want to tell that. We already have defined it. When I said E1 is the electric field strength here, it means had I placed a plus 1 Coulomb charge here, the force would have been this way. Okay, that's all. I want you to get to a feeling that around a charge at every point there is electric field strength like this. From plus Q away from it, for a minus Q towards minus Q. And E1 equals E2 equals K into Q. I'm not writing plus or minus because I'm writing only the magnitudes by R by 2 whole square. So that will be 4 KQ by R square. Two fields. Do you follow? R by 2 whole square, KQ by R square, KQ by R square. Both charges are Q and Q each. So the total E will be, since they are in the same direction, E1 plus E2. That is 8 KQ by R square, where R is the distance between them. Hope you followed this. Did you? If you followed that, let us do another one. 2 here. Plus Q here. Plus Q here. At the midpoint, what is E?
0, sir.
0. Look, we already found out force and a third charge placed at the midpoint. I'm not thinking of placing any charge like that. What I will say is plus Q has a field around it, minus Q, plus Q has a this plus Q has a field around it. At this point, it is a combination of two fields, which is a vector sum. But the two fields are opposite each other. This plus Q will be away from it. This plus Q will be away from it. And they will be equal and opposite. So E will be 0 there. All right. So if you followed, I'll continue. I started from the simplest of the problems. So there should not be any issue there. Tell me, children.
Understood, sir.
Right. I'll continue. 3. So at O, find out E. 4. At O, find E. Deliberately, I'm giving similar questions because I wanted to get a full meaning of that once for all. Find E at O. Find E at the vertex C. Come on.
No, sir. 6 root 3 k cube by a square.
First one.
Yes, sir.
Look. Any others? Tell me. Plus Q. Actually, I want you to put like this without putting, don't try. This will be E1. Plus Q, for a plus Q source charge, it will be away from plus Q. For this plus Q also it is away. And for minus Q it is towards it. So there are 3 E's like this, Bharat. Huh?
Okay, sir.
Right? All E1 is equal to E2 is equal to E3. Why? All charges are same. Though one of them is negative, the magnitude is same. That will be K Q by A by root 3 whole square, right? So what do I get? 3 KQ by A square. So this is 3 KQ by A square. This is 3 KQ by A square. The angle is 120. So the resultant is in the same direction, 3 KQ by A square. Now the third one is also 3 KQ by A square. So it will be answer is 6 KQ by A square, isn't it? So where do you get root 3 or whatever?
I forgot to square it. I wrote it 6 root 3 k cube by a square.
How can you forget? Come on. 6 KQ by A square is upwards. Right? Rishita, Anshuman, others, tell me. Deliberately, the same question, small changes I've given again and again. So what I was trying to push into your thinking is there will be many charges. Here we have taken point charge, but in practice, charges will be there distributed on the surfaces of metals or on the insulators, excess charge. Like if this bottle is there with me, if I do something like this will get a charge. So there is electric field here in this space. So it will do something to the test charges you place here. So I am asking you, I am expecting you to think that wherever some charge distribution is spread in space, around the charge distribution, there is some invisible. Invisible means you cannot see with the naked eye. Thing called electric field. And if there are many charges like that, the electric field is due to the contribution of all the charges, contribution from all the charges. And when you're finding out the net field at a given point, you'll think that field of each of is there independently of the other. Find out them, E1, E2, E3, add them according to vector addition, you get the total field. And once you get the total field, supposing you brought a test charge there, you will know what kind of a force the test charge experiences. So this is what you mean by the concept. Okay, come on. Fourth one.
Second one, fourth one I got
How much?
9 kq by square.
Which way? This way.
Both upward.
Yeah, 9 kq by square is correct now.
Fifth one 0 square.
This one is 0, correct.
Sixth one is 6 root. So 1 second.
Yeah, I'll give you time.
Root
No,
3
I've given
kq
actually
by
for you
square.
to do, right?
Root 3 kq by square. Root 3 kq by square.
Look, if I have like this, at C, I don't even worry about this Q. This will experience force, but the field here is because of these two. I told you already. In spite of having plus Q, don't worry about it because field of it below it is not defined. So field of this will be like this. Field of that will be like this. The angle is 60.
So I took the resultant.
This is A, this is A. So KQ by A square will be the field of this, field of this. Angle 60 means root 3. In the middle, exactly from the middle. This one. So while finding out, you just did not bother about this, try to understand. But since you know this field, if you want the field force on this, you will write F1Q if you write this field strength, right, into that charge. But otherwise, when you're finding out the field strength of this and this here, you'll be never worried about whether charge is placed there or not at this point. You follow the point? So field strength is there in the space. So that is how you find out.
So you are telling us for the sixth one. But the particle is somewhere else, no sir.
Where? Here.
In the sixth one,
the part at the corners.
No. The test charge that is there.
This is there. Look at this vertex, Sama. Every time this is at vertex, this is at vertex. So I can't show when this plus Q as a small, tiny one, right? Isn't it? When we said we are putting it the edges at the corners, we are putting it plus Q here, plus Q here, plus Q there.
But the vertex O is somewhere else, no sir. Vertex O is outside the triangle, no.
This is vertex C. How can vertex be outside the triangle? Vertex is vertex.
Oh.
A, B, C.
No, you pointed out that with a very big point, no sir. I thought that the particle is there.
Without giving the distance, how can I give them? It is the vertex C. A, B, C, all are same, no? Plus Q, plus Q, plus Q. So I should point out at some this
Okay,
charge,
sir.
that's isn't it? At one of the vertices, right?
Okay, sir. Okay.
Right. So this fourth and fifth, everybody got? Can I believe? Bharat, Rishita, okay. I'm comfortable that they followed it. And how about the other three?
Sir, I got it, sir.
Abhinav. Remember, I made it very, very simple, dear. Try to understand. Huh? Actually, after all these things, you should say one, oh, now, sir, now I understood the idea. So there's nothing like 10 problems or 15 problems. It's meaningless. The moment you know how to find out E at a given point due to many charges as an idea, your job is done. Bharat, that's what you mean by the concept. Huh? So can I go to the next question? Let me see. Come on, others are not saying anything. Anshuman and others.
Yes.
I'll go to the next page, Glenn. Yeah. Okay. Say seventh question, for example. The square of side A. Okay. So I have plus Q, minus Q, minus Q. Find the field strength at the center O. Find E at O. Eighth one. Plus Q, minus Q, plus Q, minus Q. O. Find E at O. Okay, ninth one. Even here, I'm making it so many questions for the same idea. Find E at one of the vertices. Come on.
Sir, first one 4 root 2 k cube by a square.
4 root 2 k cube by a square. Correct. Which way, Bharat?
Sir, downwards, sir.
Vertically downwards?
Yes, sir.
Like this?
Yes, sir.
Yeah, he's right. Now he's understood it. I can believe that. How about others? Rishita, you speak. There's so many. Just 5 students. You are.
Sir,
So you got full freedom and time to ask me.
sir, root 2 4q square by a square.
Which direction, Anshum? Abhinav?
Downward, sir.
Downwards. Right. Abhinav's ticked. Next one. Others. Rishita.
Yes, sir. Root 2 k cube by r square.
Root 2. No 4.
Wait, sir.
Look. Rishita, tell me, how should I do that?
Sir,
This is 1.
result
This is E1.
that is
Because of whom? This one.
plus Q.
And towards this only, once again, one more thing at the same place, that is E2 due to minus. Once again, due to minus this way, due to that plus also the same way. Isn't it?
Yes, sir.
I mean, there's no space I put there. Vectors can be put anywhere parallel. Try to understand. Here one I put here. But all the magnitudes are how much, Rishita? E1 equals,
2.
E2 equals, E3 equals, E4 equals K Q by A by root 2 whole square, right?
Yes, sir.
So that is 2 KQ by A square. Now in this direction, both are in the same direction, Rishita. So 4 KQ by A square. And in this direction, 4 KQ by A square. The angle is
Yes, sir,
9.
I got it, sir.
So 4 root 2 KQ by A square.
Sir,
All right?
hello. Sir, 8th one is 0, sir.
0. That's all.
9th one is a 3 root 2 k cube by 2a square.
3
root 2 k cube by 2a square.
3 root 2 KQ. Let us look at it. So when I'm finding out, say at this point, I'm just don't worry about this, right? So due to this, which way, Bharat? This way, right?
Sir,
Away. KQ by A square. Due to this, away.
away, sir. Resultant.
KQ by A square. So the resultant is how much? Root 2 KQ by A square. And there is one more here because of this. Even that will be in the same direction, right? How much is that? KQ by root 2A whole square. So both are in the same direction. So what should I do? KQ by 2A square plus root 2 KQ by A square. So where is that 3 you get, Bharat?
Sir, I said 3 root 2 k cube by 2a square, sir. Oh, sorry, sir. Sorry. I wrote everything correct, sir. In addition, I considered root 2 again both times.
So KQ by A square is taken common. You will get 1 plus 1 by 2 plus root 2. All right, children. This is 0 because plus q away, minus q towards each other. So they're equal and opposite. So 0 finally. Tell me.
Sir,
Mm.
8th one is root 2 plus 1 by 2 into k cube by a square. Yes, sir. I got.
Is there. So one of the fellows is not speaking. Anshuman, I think. Abhinav, Rishita, Sai Bharat. One more fellow. Devarchit. Parashara. Devarchit Parashara. Are you there?
Yes, sir. Yes, sir.
Why are you not speaking?
I'm getting everything. I'm understanding.
Then speak. Even they were little struggling in the middle, but now people are falling in line. No, actually, I would like to know your difficulties, which you wouldn't like to share with friends or parents or teachers. We keep hiding something, then keep struggling. Slowly, what happens in the beginning, you will think, okay, there's some more time, I learn later, and then show people that I know something. But slowly, as what happens, as the syllabus keeps piling up and you don't get marks, others get marks, you'll go into a shell. You won't tell anybody what is your issue. And all the time there'll be pressure from parents, teachers, friends to score marks, to show something. So somewhere down the line we give up. This is what going to happen to many students, actually speaking. And whereas those students, even with very limited capacity, because they are very positive and their attitude is very high, they take the help wherever is available and improve. Okay, can I go to the next page? Parashara, you only need to tell me now. Just on a small idea, I've given you so much. This idea is what, if I tell you what is this idea, what will you say, Abhinav? What is the idea behind the whole, all the problems? Abhinav, this is the idea. What do you call it as? Principle of?
Superposition.
Yes, superposition of fields. Superposition means what? Do you know? Putting one on the other.
Assemble of charges.
No, assembly of charges is okay, but superposition is adding. Like putting one over the other is superposition. So you should be able to tell that yes, all these problems are based on this idea called principle of superposition of electric fields. So this is how physics works. Do you know? You cannot simply say that these 10 sums are different. They're all one and same. Okay. Can I continue now?
Yes, sir.
And Parashara?
Yes, sir.
Okay. Right. Now, whatever number there, I forgot. 8, 9. I'll give more problems. Don't worry. One idea, many problems. So charges are placed up to infinity. Okay. Find electric field strength at x equals 0 due to all these charges. Come on. So, Sai Bharat, are you doing?
So yes, sir. Doing.
Okay.
Sir, 4.
Abhinav.
Sir, 4 cube by 3, sir.
4k cube by 3, most likely, isn't it? And if you did that, continue the question, if the alternating charges are of negative, these are negative, find EFS at x equals 0. That means one is plus q, that is minus q, plus q, minus q, like that. This is 1, this is 2. Instead of me showing this, one of you, those who are not able to set it up, just tell me how you want to start. I'll start like that and help you in making you do the question. Come on, Rishita. Come on, children, you need to speak. So at this point, Rishita, what is the direction of electric field strength of plus Q?
I got it.
Away from it, sir.
Away from it. Right?
You have to add all the charges till infinity.
The electric field of first Q will be a little longer like this, right? Because distance is small. But because of this plus Q, little smaller, isn't it? Because distance is more. Because this plus Q, even little smaller. Like that, isn't it? So the total field is in this direction. Isn't it, so children? That kind of visual picture you need to get. So what will be E, Rishita? KQ by 1 square plus KQ by 2 square plus KQ by 4 square plus KQ by 8 square, like that. So KQ, if I take common, 1 plus 1 by 4 plus 1 by 16 plus 1 by 64 plus dash dash. So KQ into A by 1 minus R. Isn't it so? So 4 KQ by 3. Now in the second case, E equals, I can say KQ by A square minus KQ by 2 square. Why? If due to this it is away, due to minus it is towards it, right? Minus towards it. So plus KQ by 4 square minus KQ by 8 square and so on. That is KQ into 1 minus 1 by 4 plus 1 by 16 minus 1 by 64. So KQ by 1 minus of minus 1 by 4. Isn't it so? Tell me.
Yes, sir.
So,
For
Anshuman,
second case, all charges are negative, sir.
if the alternating charges are of negative.
Alternative. Okay, sir.
So, Anshuman,
Yes, sir.
are you okay with the problems?
Yes, sir.
Hmm?
Yes, sir.
Tell me, in the beginning, I have no problem in teaching you very, very small things also.
Comfortable, sir.
Sure. Huh?
Yes, sir.
Right. Can I continue then?
Yes, sir.
Now, I'll change the question slightly. There's a pendulum of length L. Length L, mass of this is M. There is a charge on it. Okay, that charge is Q. Now, a uniform field E is applied like this. When you show parallel lines like this and a uniform field, you say everywhere E is same is the meaning. More of that we'll talk later. Find out the angle made by the pendulum in equilibrium. So you need to tell me how I proceed. One of you can keep talking to me. Come on. Children, why don't you speak? No, if you speak, actually, I'll know your difficulties, children.
Hello, sir.
Yes.
Sir, in equilibrium, I have to balance the forces, so tension
No, first
equals.
of all, what is equilibrium? What is going to happen? Tell me. Why the pendulum moves? All that you should tell first, right?
Sir, due to the E, it will experience a force.
In the direction of E.
Yeah.
Right? So that's how you need to start. So it will be going like that. Huh? So what kind of a force will act? EQ. Isn't it so? How? E equals F by Q. Isn't it so? And then anyway there is tension and there is weight. So this is what you need to do first. Say this angle is theta. All right. So for the equilibrium, what will you do? You resolve the.
Sir, that angle theta is small angle or big angle, sir?
Doesn't matter now. I did not mention, no. If this is theta, this will be theta. Right? This will be t cos theta. This will be t sin theta. For equilibrium, t cos theta minus mg equals 0. T sin theta minus eq equals 0. So take it that side, take it this side, divide one by the other, tan theta equals eq by mg.
Sir, I got the same answer, sir.
Okay.
So and you said to take a theta is same, so we can take it as sin theta also. When the angle is small, can we say?
This angle won't be small or need not be small. I did not mention for that reason. Huh?
Okay, sir.
Can I go to the next question then? Others, tell me.
Yes, sir.
in this region have one E equals 10 to the power 4 Newton per Coulomb. Here, one proton is released from rest. Find its velocity. It means protons. Velocity at t equals 10 seconds. The field is there all over the region. Come on. This P stands for proton. I told you already about this, right? Release from rest. So U equals 0. Now, proton will experience a force because of E. How much? EQ. So its acceleration is EQ by mass. E is constant, Q is constant, M is constant. So acceleration is constant. So when acceleration is constant, V equals U plus AT. So V equals 0 plus E 10 to the power 4 Q 1.6 into 10 to the power minus 19. For proton also same charge. EQ by mass of proton. Mass of proton can be written as, for example, 1.6 into 10 to the power minus 27 into time 10 seconds. All right. So this went away. So 10 to the power 4 and this is minus 19, 1, 5. If it goes 32. Right? 32 minus 19. So finally, what am I getting? Tell me. Ten to the power so much velocity, of course. This is not a very meaningful problem because it's going beyond the speed of light. So
Sir,
what?
if the E value is different means E value, if the given E value is different means,
Let me make it E value some 10 if I make Newton per Coulomb, then 11. Oh, it's becoming even more.
I think we should decrease, sir.
Decrease it. Okay. So make it some 27 something. Remember that velocity cannot be greater than the speed of light. Do you follow? Do you understand my point? So numbers were not thought properly. But E value is okay. Proton is okay. Mass is okay. So let me put it here. So that high speeds, this equation doesn't work. Here I'll put some 10 to the power minus 2. If I put anything happens, check it. 10 to the power minus 4, minus 2, whatever. So what will I get then? EQ by M, right? So minus 27, 28. 28
Yes,
minus
sir.
20.
Now we are getting.
10 to the power?
We are
How much?
getting 10 to the power 7.
7 is not a bad thing. Okay. So to be careful, you cannot make it greater than 10 to the power 8. All right. Now, one more question here. There is some electric field formed between the plates of a parallel plate capacitor. You do not have to worry about parallel plate capacitor as such, but what it means is E is like this all over. This is what you mean by uniform field. Now, this value is E. One plus charge Q is projected into this with V0. Huh? So it would have gone this way if the field was not there, but it will go like that. Okay. Find out the displacement of the particle in the y direction. If I take x and y like this, find out this y. Length of the plates is L. First, understand the question carefully. How about your integration, children? Is it all right with you?
Sir,
Sir, good, sir.
you will travel along E, no, sir. Along E it will travel, no, sir.
No, dear. It is projected perpendicularly. It was not projected like this, or this is projected this way, perpendicular to it. So Q will apply for, let me say this minus Q, sorry. Right.
Yes, sir.
Minus Q, that is. How about your integration, children? I'm not speaking.
Sir, is it L cos theta?
Integration, I'm asking.
Sir, integration good, sir. It's better. It's best, sir.
You can do that, no? Because tomorrow
Yes,
I have to do that. Now, look at this. He's telling some y is how much, means he's telling some L cos.
L cos theta.
Where is theta?
Sir, I'm creating an angle, sir, that in.
So you cannot give the angle in terms of some other thing you thought, no? You should get in terms of what is given. Look at this. There will be a force acting in this direction, isn't it? How much force? EQ. So by m is the acceleration. This charged particle's mass is m. Right? And this velocity v0 will remain as v0. Believe me, because force is acting only in this direction. So this will be remaining as v0. Do you follow my point? So by the
I
time
didn't
it comes
got
out,
this question. Sir, I didn't understand. I didn't understand.
where?
Where means I didn't understand the question. Basically,
Tell me. We projected a
it's like
particle
how
in
you got the.
this was already discussed, no? This negative charge is going to be.
That one I understood, sir.
So
How to find why I didn't understood.
I'm doing that only now, right?
Okay, sir.
I told you there's a force in this direction. How much force? Force by mass. Force is what? EQ. EQ by m is the acceleration in this direction, right? Huh?
Yes, sir. Yes, sir.
So this velocity will remain same. That only I'm talking. What else I'm talking?
Okay, sir.
This is the time when it's coming out, I'm showing. This EQ by m will be there all the time upwards, because E is this way, minus charge is this way, EQ force will be opposite to E. So that EQ by m is the acceleration in y direction. And in this direction, there is no acceleration, I'm telling you, because this is no force in this direction. Tell me. So if this is the y displacement here, y equals, can I not write half at square. U is 0 in this direction, in the y direction. Only v is there in this direction. Huh? So ut plus half at square. U is 0 in y direction. So half at square. How much is that? Y equals half into a is how much? Eq by m into t square. But t I don't know. That will be half Eq by m into t will be this total distance L divided by this unknown unchanged speed v naught. So L by v naught whole square. So in terms of everything which is known is given. Half Eq by m L square by v square is the y displacement. Do that. I'll continue that in the next page. Now tell me, Devarchit.
I got it, sir.
When you say you got it, are you clear that you got the physics of it?
Yes,
Or
sir.
only these steps?
Physics, sir.
I'll still continue with the same thing for a while, but complete this calculation. Now, may I continue?
Yes, sir.
You know y equals y, I wrote half at square. Tell me. Why did I make initial velocity 0?
Because there is no initial velocity along y.
That's correct. The whole velocity is along v0. That will not change. Why? Because force is only in y direction.
Y direction.
Right. Now the same thing I'll show you a little more. Look, we had things like this. This is plus, this is minus, plus minus. All this will come again, children. The lesson is huge, very big. Takes one more week actually to finish it. Now, the electron, negative charge would have gone straight like this, right? If there was no field. But there is a field like this. The field will apply force in this upward direction. So by the time it entered on, it starts deflecting, right? Deflecting like this, deflecting like this, deflecting like this. It will go like that, unless it touches the plates, of course. That all depends on the initial velocity. So it will go like this. By the time it comes out, this V0 remains as V0, but the body gets a velocity in this direction. This is what we calculated as Y. This is not a straight line, children. This is a curved line, okay? Actually, I'll draw it again. It will be a parabolic path. It's a parabola you can show mathematically. Like that. How will you show it's a parabola, children? Just now I wrote the distance in y direction is y equals half a eq by m into any distance x, I'll write, not L. L is the total length. But any distance x, if I write, x square by v naught square will be this is v naught is the speed with which it was entering. So is it not kx square formula? Everything else is constant here, right? So it's a parabola equation. So try to understand. But when it came out, I wrote this x as L by v in the previous case. when it came to come out. That's why that answer we wrote like that. But at this point, remember, the particle path will be like that, but it just goes out tangentially because no more field. So this velocity you get is a combination of this V0 and the V it attained in this direction, Vy. This angle, if you call alpha, first of all, V equals V0 square plus Vy square under root. V0 will be V0. Vy will be EQ by M into T. T is L by V0. This square plus whole of this square under root is the velocity when it comes out. And also the tan alpha will be the direction in which it comes out will be. This will be Vy, this will be V0. So Vy by V0. The whole discussion of negative charge in the field between two parallel plates of a capacitor we discussed. It comes out with this direction. It has got this magnitude of speed, and the equation of the motion is a parabola. And if x equals L, that is when it comes out of the thing. This y is the displacement in y direction. That means it should have gone this way, but because the force applied, but it's going that way. It is similar to something like this. If I throw a ball with a velocity v0 under gravity, it goes like that. Here we ignored gravity for the mass because gravity also will be there if it is in laboratory, right? So we ignored gravity. So all this is because gravitational force will be very small compared to the electric force. Tell me
Sir,
now.
if V0 is not constant, sir, then
If V0 will be, what do you mean by V0 is not constant? It will be constant. No, once you throw it with V0, it will go with V0. There is no force in this direction to change this. Because you wanted V0 to be constant, it won't be constant. It won't be varying. V0 is the velocity you gave. It won't change. It goes like that because there is no force in this direction. Don't say if V0 is not constant. V0 is, you give V0 10 meters per second, that will go with 10 meters per second in this direction. Like here, you throw a ball with 10 meters per second like this, it will remain as 10 only all the time. But in this direction, the ball gets extra velocity because of gravity. So the total velocity will be the sum of these two. So don't say if 10 is not constant. How will 10 change? There is no force acceleration provided in that. Tell me. Parashar,
got it, sir. Got it, sir.
Right. Other children? So the heading is what? Motion of a charged particle in a uniform electric field between two plates. That was the heading. Motion of a charged particle.
Sir, discussing after this.
Tell me.
Did you give the just a mind map of the capacitors or just you are starting it?
Oh, capacitors will come later, much later. Don't worry about this only field. Capacitor comes after one more month, not now. Just a uniform. It is a motion of a charged particle in a uniform field. That's all, which is spread over a wide region. Just I use the word capacitor because that's where it is practically formed. Lessons are very, very systematic. You don't jump. You will see how big, how deep, and how and wide one lesson is. By the time you finished it, even halfway through, when I summarize, you'll think, oh, so much is there. This should be over, potential should be over, Gauss law should be over, current history should be over, and then I'll come to capacitors. So it's a long way. Delhi bahut dur hai. You are just beginning. Since actually the whole idea was we are talking about electric field, Sai Bharat. So why electric field actually? We would like to know what happens in that electric field if a charged particle is thrown, right? So the whole thing is about force and field. I told you the whole lesson Electricity magnetism is about fields, forces, potential energies. That's all. Nothing else. Everything is that. All right. Tomorrow I'll come prepared with, I'll give you a heading here. Electric field strength due to continuous charge distributions is the heading I'm going to discuss. Oh, before that, I think I should discuss a dipole. Electric dipole, okay. Electric dipole first. And after that, of course, we don't know. It all depends on your speed. This is next one. This is the other one. Today, tomorrow, day after tomorrow, probably we should be able to do. All right. So for the present, I'll close. All right, children.
Thank you, sir.
Thank you, sir.
Thank you,
Bye.
sir.
Good night.